In today's vlog, we're going to talk about how the pressure, temperature, and volume play a role in the design choice. When building this cannon, we are given two tennis ball cans with the tops, scissors, and 18 inches of tape.
Yeah, so basically, our teacher gave us this awesome document. I hope you guys are having a nice time and all of that while we're continuing working. Sorry if my face is cropped up. We have some technical issues, but that's beside the point. Anyway, so hope you guys are doing well. We're gonna see you in a little while in this little universe of yours. Hope you're not dying a painful death in some civil war of some type or some occasion. But anyway,
Hopefully
I will
by
hope take care. We'll see you in a suture part, which we're gonna overdub dramatically. Take care. Bye.
This is a blueprint we made for our cannon.
This is a blueprint of our cannon, and instead of using just two tennis ball cannons put together in like one big barrel, we decided that it would be best to cut one of them in half and use one half as the base and one half as a kind of combustion chamber area. One of the reasons is because obviously there won't be much deviation in the angle. It'll be set because it's taped together. And also, there will be less volume in here. And because we're getting the same amount of explosives as everyone else, there will be more pressure in here because there's less volume but the same amount of explosives. So when it explodes, there will be more pressure. Also, even though we have a shorter barrel because it's really 1.5 of these tennis ball canisters, it doesn't really matter. Barrels in normal cannons usually increase the range and accuracy, but that's for cannons where the cannonballs sit here and the explosives are here. Our cannonball, or foam ball, is going to be resting out here. So there isn't, no matter how long the barrel is, where the explosives are, it's not going to be affecting the ball because the ball is just shooting straight out.
Okay, guys, welcome back to Isaac Bear Early College High School in this awesome chemistry lab. Today we're going to be talking about how we're going to build our cannon. So, basically, we have a couple of materials that we need to do to get the cannon created. So, we first have to have two tennis ball cans with some tops, yeah, because tops are important. Then we have to have scissors, because we have to put a hole in some of those cans, because we have to make the cannon go boom, and in the way that we want it to go boom. And then we also need to have an 18-inch piece of tape, man. So how are we going to do this? Well, first of all, we're going to cut one of the tennis ball canisters in half. And then we're going to cut the end of the other canister so it is open on both sides because it's going to be more efficient that way. Yeah. Then we're going to tape the closed end off the first canister onto a barrel to act as the combustion chamber so we can have more efficient boom and have longer projectile range and cause the awesome thing to go boom more effectively. And then we're going to have the other half, which is going to act as a base, so we cannot, like, it won't flip over and be messed up in all horrible ways. It's going to be positioned so that the end of the combustion chamber is touching relatively close or near close to the ground. This is so that during when we go boom and we're going to have some awesome projectile firing up in this house, we're going to have the barrel that will not cause too much damage to the trajectory, so we can have a much more efficient cannon ride, and so that we won't have a horrible margin of error. Anyway, to the next scene, overdubbing!
This is a simulation for our cannon. We chose 42 degrees as our angle, and according to that and an initial speed of 9.5 meters per second, this is what it will look like. And supposedly, without air resistance, we will get 10.3 meters of range.
And we're going to talk about the last thing that really is a part of our requirement, and that is the chemical equation for the combustion of ethanol and oxygen. And we first need to know what ethanol, the chemical formula for ethanol is, and that is C2H5OH, which could be even more commonly known as C2H6O. So at this point, we are going to have to use combustion. And if it's an oxygen, it's probably diatomic oxygen, which means we're going to use O2. So technically, the balanced chemical equation for the combustion of ethanol and oxygen is C2H5OH plus 3 moles of diatomic oxygen is equivalent to 2 moles of carbon dioxide plus 3 moles of water, also known as H2O. This will be useful for our experiment since we are going to be using 2 milliliters of ethanol, and it's going to react and it's going to cause the ball to escape the cannon and cause some type of trajectory. This is our main goal throughout the project, and we will succeed in doing so. Take care.
So that concludes our discussion about the design of our cannon, and in the near future you should expect to see the actual construction of our cannon and the firing.
Cannon are better than Nikon!